All right, here are solutions. Clear that out. For quiz 8 for Math 243. So let's see. First one here. I suspect that missing class on Wednesday decreases the probability that a student will pass their Friday quiz. Don't know why there's two periods there. To test this claim, I note that only 78, it's X, of the 110, that's N, quizzes of students that miss class on received a, this isn't even English. To test this claim, I note that only 78 of the 110 quizzes of students that missed class on Wednesday received a passing grade. I know that the pass rate for all students on quizzes is 80%. All right, so this 80% here is P naught, and 78 divided by 110 is P hat. Sample proportion, population proportion. Test the claim that missing class leads to a lower, that'll be key, pass rate. With 99% confidence, that tells us that alpha is 0.01. Null and alternative hypotheses. The null and alternative will both always compare P and P naught being 0.80 in this example. Null hypothesis is always that they're equal. For the alternative hypothesis, you have to read the problem. Because it says lower here, we want a less than sign here. We have a left-tailed test. Maybe I should make this a little bit more legible. State and justify the shape, center, and spread of the distribution. Shape better end up being approximately normal, or else we can't deal with it in this class. It is approximately normal because of the central limit theorem and the fact that n times p naught times 1 minus p naught is greater than or equal to 10. Could check that if you really wanted me to. I would say that n is 110. P naught is 78 divided by 110. And 1 minus p naught is what, 32 over 110? And when I finally get this in and hit enter, I should get a number bigger than 10. I do. Good. Approximately normal. Center, I'd like to use P. I don't know P, but I start out by assuming that P equals P naught. So for my center, I'll have 0.80. And for my spread, I'll do the square root of P naught times 1 minus P naught divided by N, which is the square root of 0.8 times 0.2 divided by 110. Some number, whatever that's equal to. Okay, sketch the appropriate picture using whatever method you want. So I guess I better do it both ways. You don't have to. If we do the classical method or the p-value method, either way, we're going to draw a picture where the shape is approximately normal and where the center is, where did I say it was, 0.80 up there? For the classical method, we have to first set up our rejection regions. To figure out the rejection regions, we go up here and we say, all right, alpha is 0.01. So what that means is I want some area down here, some shaded region, where this area is just 0.01. Notice on the left, because it's a left-tailed test, I can figure out what z-score corresponds with the critical value, the boundary of this, by using the inverse norm function on my calculator. Second, distributions, inverse norm. The area below in this case is 0.01. I want a z-score, so I'll put comma 0, comma 1, and it gives me negative 2.33 if I round it a little. Okay. What this is saying is that if I get a test statistic less than negative 2.33, then I'm going to reject my null hypothesis. So let's figure out what the test statistic is. Let's go over to stat, and then tests, and then one prop z-test. Let's see, P naught is equal to 0.80, X is equal to 78, N is equal to 110, and my alternative hypothesis was that P is less than P naught. Hit enter here. Go either calculate or draw. Either one will give you all the information you want. I'll do draw this time, why not? What it tells me is that my test statistic is negative 2.38. Oh, barely. All right, so I got a test statistic. This is not drawn to scale out here of negative 2.38. And so I will say because my test statistic, which was negative 2.38, is in the rejection region, there is sufficient evidence to reject the null hypothesis and conclude whatever we were talking about in this problem, that missing class on Wednesday decreases pass rate. Sure. Had I done this using the p-value method, I wouldn't have needed to set up these rejection regions. I would have just jumped straight to the part where I find that my test statistic is negative 2.38. That's the test statistic that corresponds with this value of p hat, 78 over 110. I guess I could put that into my picture here. That's this up here. So 78 out of 110, whatever proportion that is, has a corresponding test statistic of negative 2.38. The question is that low enough so that it would fall in the rejection region that we didn't set up? The answer to that question is yes. The reason I know that is because this shaded area right here is only 0.0086. So what that's saying is this shaded area, because the p-value, which was 0.0086, is less than alpha, I draw this conclusion. So either way, you only have to do one of these two methods. There's the different conclusions. That's finally the end of the first problem. Unfortunately, that's not the end. We got to do this second problem here. Second problem, to further examine if missing class decreases test scores, I randomly choose 10 students and compare their quiz grade on a week that they missed class to their quiz grade during a week they did not miss class. The data is summarized before. When you don't miss the class, when you miss the class, the difference. Notice that we have matched pairs here. These are dependent samples. When you have dependent samples, you can more or less just ignore all this stuff and just use this data over here. State the null and alternative hypothesis. The null hypothesis, well, let's see, maybe I should go through and define some things here. First of all, I got 10 students. That's N. Let's see, I know that their average test, the difference in their test scores was negative 2.7. D hat, I believe, is what your book uses for that. And the standard deviation was 3.85. That's S with a little d next to it. Okay, so mu, this thing that I don't know, I want to compare that to mu naught. Mu naught will always be 0 in these matched pairs tests in our class. So I want to compare mu and 0. I'll say it's equals in my null hypothesis. In my alternative hypothesis, I'll have to read the problem. In the problem here, it says that it decreases. Somewhere we'll see the word decreases. There it is, decreases. Because that says decreases, I put a less than sign here, and I have a left-tailed test. State and justify the shape center spread. Shape is approximately normal. Maybe by assumption. What do you mean by assumption? Because it says it in the problem. If you read up here, assume a normal probability plot indicates that the data is approximately normal. Center is 0. Let's see, I guess it would be mu naught equals 0. If you just say mu equals 0, I don't care. For the spread, we want to use S sub d divided by the square root of n. S sub d is given to us as 3.85. N is given to us as 10. Shape center spread. Draw the picture. Fine. I have to do it twice. You only have to do it once. You most likely will use the p-value method over here because it's a little bit easier. But you might not. You might use the classical method. Hang on. Okay, so when you're drawing your pictures, in either case, the center is 0. That's... Do I care? I don't care. The center is 0. When we do this to sample stuff, I'm just going to have you write one line of data. The center is 0. What we need to figure out is if our difference here, our test statistic, is negative 2.7. Yeah, I guess I should have 2 rows. Fine. Center is 0. Negative 2.7 would be out here. Oh, going out of order. Slow down. First thing I want to do with classical is set up my rejection regions. In order to set up my rejection region or regions, I look up here and see that it's a left-tailed test and that alpha is equal to, it doesn't say. I'm going to have to add that alpha equals point, I don't know, 0.05. Sure. Alpha equals 0.05. So what that means is you want to shade in a region out here that has an area of 0.05. What you need to figure out is what critical value corresponds with kind of the boundary of that region. Unfortunately, this is a t distribution. Should have written that up here. T distribution, because sigma is unknown. So you can either use the inverse t function on your calculator if you have it. This calculator I'm using doesn't. Or you have to go to the tables. We want to know the point that has points. So if you go to a t-table, it'll look something like this. We want 0.05 to be our tail probability. And if you go down to 9 degrees of freedom is just n minus 1, you get 1.833. So if it were on this side, it would be 1.833. Since it's on this side, it's negative 1.833. That's our critical value. When we do our hypothesis testing over here, we'll take our test statistic and we'll compare it to that value. So the way you do that is if you hit stat and then go over to tests, and then it's a t-test because it's a t-distribution here. You could either put in this data or statistics about the data. I'm just going to put statistics because they're summarized for me here. Mu naught is 0. X bar, it's d bar in this case, it's negative 2.7. Standard deviation, 3.85. N is equal to 10. And my alternative hypothesis is that mu is less than mu naught. You can either calculate or draw the picture. Guess I'm going to draw the picture again. And then I'm going to be patient and wait for this thing to draw, even though it's kind of slow and I'm kind of hungry. When this finishes drawing, it will give me the test statistic down here. It says t equals negative 2.2 something. So this isn't exactly to scale, but somewhere out here I got negative 2.2. That's my test statistic. State my conclusion. Can I just repeat this? It's really the exact same, but I'll rewrite it. Because the test statistic, which is negative 2.2, falls within rejection region, and then I will say there is sufficient evidence to reject the null hypothesis and conclude, try that again, and conclude that test scores decrease for missing class, or something like that. If you were going to do this the p-value method, you wouldn't have to use that t-table. You wouldn't have to set up your rejection regions. You'd jump straight to here. You'd say that my test statistic is negative 2.2. That's what corresponds with this difference of negative 2.7. I guess I could write that up here. And the area to the left of that negative 2.2 is 0.0269. And so I would say because my p-value is less than alpha, alpha was 0.05. Because my p-value is less than alpha, this conclusion here. All right, that is finally the end of this ridiculously long quiz. Sorry.